Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When anisole, methoxybenzene, C6H5-O-CH3, is treated with excess concentrated high under reflux, the CO bond of the ether is cleaved by high. Moving on to the next step. Anisole is an aryl alkyl ether. When treated with high, the bond that cleaves is the weaker alkyl CO bond. The ARO bond is stronger due to resonance with the ring. The iodide ion acts as a nucleophile and attacks the methyl carbon, SN2, not the aryl carbon. Aryl CO bonds are not cleaved by SN2. Moving on to the next step. The nucleophilic iodide, I, attacks the methyl group via SN2, breaking the OCH3 bond. This produces phenol, C6H5-O, and methyl iodide, CH3I. And for the final step, the proton from high first protonates the oxygen of anisole, forming the oxonium ion, making the methyl carbon more electrophilic. Then I attacks the methyl group to give phenol and CH3I. Option A. Iodobenzene plus CH3I would require cleavage of the ARO bond, which does not occur under these conditions. Option B. Iodobenzene plus CH3O would require ARO bond cleavage and no iodide incorporation on carbon, which is incorrect. Option D. Phenol plus CH3CH2I is incorrect because there is no ethyl group present in anisole. Option C. Phenol plus CH3I is the correct product of high cleavage of anisole at the alkyl CO bond. Therefore, the correct answer is C. Therefore, the correct answer is option C.